Use algebra to prove that the square of any natural number is either a multiple of 3 or 1 more than a multiple of 3. So you could try some numbers out if you want, but it does say to prove it using algebra, because if you just try numbers out, yes, it gives some examples, but it doesn't show that it's true for all numbers. We actually have to show it for all numbers. Now, if you split this into odd and even, it's not going to work. In fact, because we're trying to show a multiple of 3, we're going to split it into 3 cases. Case 1, n is a multiple of 3. So n is going to equal 3p, where p is a whole number. Case 2, n is 1 more than a multiple of 3. So that's going to mean that n is just 3p plus 1, because I've got a multiple of 3, then I'm adding 1 to it. And then case 3, you can either go with n is 2 more than a multiple of 3, or equivalently, it's 1 less. That's going to make the algebra slightly more simple, so that's what I'm going to go with. Okay, but that basically covers every single possible number. Every natural number has to be one of these. Okay, so case 1, we're going to get n squared equal to 3p squared, which is then 9p squared, which is 3 times 3p squared. And this is a multiple of 3, because it's 3 times something. Case 2, 3p plus 1 squared. Now don't forget, this is actually a double bracket. So either write out as a double bracket or kind of do it in your head. You're going to get 9p squared, then we've got these cross multiplying terms, 3p times 1 and 1 times 3p, that gives 6p, and then plus 1. I can factorize the 3 out of the first two expressions, so I've got 3p squared plus 2p, and I'm left with this extra 1. So this is 1 more than a multiple of 3. That just leaves us with the very final one. So n squared is 3p minus 1 squared. We get almost the same answer, but it's 9p squared minus 6p plus 1. Which again is 1 more than a multiple of 3. And we've shown it. We've considered every possible number, splitting it into these 3 cases. We've always got multiple of 3 or 1 more than a multiple of 3. And so to finish, we can just say the result follows. Proof complete, QED, however you want to finish it off. Great. Now let's just say you didn't go with the 3p minus 1. Let me just show you how it would have worked out. If instead we're going with n equals 3p plus 2. Okay, it's just a little bit more awkward, but it will work out. So now I'm going to get 9p squared plus 6p plus 6p, that's plus 12p plus 4. And then I would write it as plus 3 here, plus 1. And then try to show that the first 3 terms are a multiple of 3, which they are because we can factorize the 3 out like this. So it works absolutely fine. But I just bear in mind, the minus 1 bit. When you start talking about consecutive numbers, it's not always good to just do n plus 1, n plus 2. Sometimes actually doing an n minus 1 can make the calculation a little bit easier, and so it's worth doing. Right, well done on this question.